So, yeah, as introduced to you all by Rajesh, my actual research was in MEMS technology. Probably many of you are acquainted with that area. That is where all our signal processing happens on an integrated circuit, which is designed or realized on a silicon wafer. But all the sensing activity happens outside the silicon. So that used to be the case. And somehow to make things power saving, to make it rugged, to make it robust and portable, people wanted to have even sensors onto the silicon wafer. And that was the initial thought process. And with that, domain of micro electromechanical systems was conceptualized. And today, if you see in our mobile phone, we have all sensors that you talk of, probably a gyro or an accelerometer or a thermal sensor or many of that. So all that was possible because people thought of bringing these sensors onto the silicon wafer. And to start with, they also even demonstrated that silicon is as good material as steel, which is usually used in developing these sensors. By bringing that into the silicon wafer, people also made it CMOS compatible, all that. This particular topic, today's topic, is little deviating away from MEMS technology, but that too can be used, and that could be our future study. So the problem statement came to us from our medical fraternity. The people in the audio department came up saying that for people who have disability in speaking, that is that sound box what we talk of, in some cases by surgery it had to be removed, and now once it is removed they lose the ability of speaking. For that there needs to be a replacement. For that, what you have taken out is larynx, the artificial one. There are mechanical type of larynx, but today we will be talking of electrical type of larynx, which is called as electrolarynx. What is displayed on the screen is one such device. It is electrically powered device. Very simple technology. So what you see on the screen is one such device which is manufactured by Servox. If you break open that, there is nothing complex electronics there. There is simple one square wave generator. Its duty cycle can be controlled. So two buttons what you see is one power button, the other one which controls the duty cycle. And that square wave what is generated, it actually drives a piston, and that piston goes and hits a membrane. The top surface of this device is a membrane, and that starts vibrating as soon as the square wave is produced. So this is doing the job of larynx, the sound vibrations. So just to give you some background about speech production. So when we have ability to speak, we take it granted, but actually it is a very, very complex activity that is involved. Three main things that are required in speech production are the lungs, which provides that energy that is required for generating that sound vibrations. The larynx, the sound box, is the one which converts that energy into vibrations. If that alone is there, you just get a sound like now this sound is modulated using articulators like tongue, the mouth, nose, all that. Using the movement of all this, a intelligible voice is created. So when the larynx is removed, since the sound box is now missing, the person will not be able to speak. So people have come up with artificial larynx. At present, I am showing only the battery operated ones. There are two types. One is intraoral. You can just see that it has to be placed inside the mouth when someone intends to speak. The other one is extraoral, which is you just put it below the neck at appropriate position, power on the square wave generator, then you start speaking. So I had a video, but I'm unable to play that. You can watch YouTube videos. How does the voice that is generated this way looks like? It is almost like a robotic voice. Now, when this problem was brought to us, what is that research we can do on this product? So we just started studying this product. This thing was, whenever you intend to speak, you have to hold this device below the neck. So that means that your one hand is always engaged in holding this device. So in many public speaking, to make your speech effective, you would like to make use of both your hands. So all that freedom you lose once your hand is engaged in holding this device. So that was one scope we identified. Can I make this device a hands-free device? One more is not only holding it, even whenever you intend to speak, you have to press this power button. Probably that is required because one, you want to save your battery, and another one is you do not want circuit be powered and some vibration comes, something unwanted things happen, all that. So again, this was another scope for improvement. Can we adopt auto turn on mechanism? Once if I can do this, there is an opportunity for making it hands-free. One more thing is, it was generating a square wave with duty cycle adjustable between 40% to 90%. But if people have studied the signal the natural larynx generates, it is not a square wave. It is much closer to a sine wave, if not sine. It is not sine wave, but closer to sine wave. So that means that you are generating additional waveform, which is not actually required. With that, you are wasting unnecessary power. So is it possible to save some power by doing this? Also, the natural larynx was inside your neck. Now the artificial larynx is outside the neck. Now whatever signal you generate, it is passing through your skin and that actually reaching inside. So that means that there is one additional transfer function of this skin that is coming, and that is doing the job of altering the waveform what is generated. This was one more scope for the improvement. Again, the battery that was used was nickel metal hydride battery. Since our intention also was to make it variable type, to make it compact, we were also exploring, is there any possibility of reducing the battery size, with that the whole device size. If you see that first page, the device when I displayed, most of the space is occupied by the battery. So can I go for lithium ion battery and make it more compact? And can I make use of power saving methodology what we use in VLSI technology to make it power efficient? So with this analysis, we fixed up some objectives for our research. So one of that is it possible to cancel that neck transfer function? That is, whatever signal what you generate outside the neck, can it be coming very close to what it would have been if it was generated inside the neck? People have studied the signal the larynx, natural larynx generates. The first row is that. People have also studied the neck transfer function. In the second row, the middle one is that. So now what does electrolarynx do? It generates a square wave. That signal gets convolved with the transfer function of the neck, and that resulting signal what is shown on the rightmost side in the second row is actually the signal that is getting modulated by your modulators. See that this signal is different from the signal that is generated from larynx. Now, is it possible for me to make this signal close to the one which larynx generates? So what I wanted is in the left, what I'm getting is in the right, in the present mechanism. Now, somehow, if I'm able to generate the signal what I want, that is whatever natural larynx would have given, if I'm able to generate using electrolarynx, still it will not help me, because what I generate is not inside the neck, it is outside. So that signal again will get convolved with neck transfer function, and it gives me the third signal. Again, it is not what I intend to get. So wanted is on the left hand side. I actually generated it, but since it was passing through the neck transfer function, I actually get what is on the right. Now, what is the way forward? Suppose what I want is convolved with the neck transfer function, that is the inverse of neck transfer function. The first signal I get, that is what natural larynx would have generated, that is on the rightmost side. That signal, I combine it with inverse of the neck effect, and that signal I generate. Now when it passes through neck transfer function, this convolution operation cancels the effect of neck transfer function and results in a signal which the natural larynx would have generated. So this was our approach in solving the problem. Now, how do I generate this signal? So I have to generate a signal which is the natural larynx signal convolved with neck transfer function, which looks similar to the one shown below. How do we do as an electronics engineer? A simple way to do that is whatever signal you want to generate, you sample them, convert that into digital signal or binary values, and put it in a lookup table. And that is what is demonstrated here. I'm just showing that in this particular case, I've converted that into 64 samples. I'm sure people with electronics background will know that when I want to sample it, what is that sampling frequency or sampling rate that is required. So that I'm not discussing here. So I'm just showing just the basic approach of doing it. So convert that into 64 samples. To address those 64 samples that are put up in the lookup table, you need 6 address lines. So that is what is shown. Now your approach will be start sending the stored data sample by sample into a D to A converter, followed by that have a low pass filter, and then you will get a rough signal which is very close to what you intend to generate. Whenever you want to intend to speak, this signal should start getting generated. I do not want to do this manually by pressing a button. So how do we approach this? Again, we took help from our medical fraternity, and whenever you intend to speak, the lower jaw moves, and that helps you in knowing when you are intending to speak. So what we did is we took a strain sensor, and near the jaw, as per the guidelines from health professionals, we identified the suitable location for mounting the strain sensor. And that once if you have a sensor which converts the strain into resistance, then using Wheatstone bridge and the instrumentation amplifier, you can convert this resistance change into voltage change. And that signal what you get is put into Atmega microcontroller, the analog pin, which is converted into digital signal using the internal A to D converter. Now, when the mouth is closed, the voltage levels that are generated is about 0.12 volts to 1.18 volts. That is the range. When you open the mouth, that is, say when you intend to speak, the voltage generated is about 1.34 to 3.29. And when you chew, it is much higher voltage. So that means that you are interested in a window of 1.34 volts to 3.29 volts. So that again we programmed using the microcontroller. We converted the signal that is coming out through atmega. If the voltage is within this range, you convert it to one digital level. If it is beyond that, you put it as 0. So using a window detector model, you can do that. So once if you have this 1 and 0, this signal can be made use for powering on your circuit. By opting this, we also parallelly did statistical analysis, all that, and some results I'm showing here. So the box plot, what you see here, normal servox, what is the reaction time? The servox and the normal, that is naturally when you speak, the servox and our module. You find that our module is almost responding instantly when you intend to speak. It is coming very close to the normal plot, whereas servox has a delayed response. This is when you initiate the speech. When you terminate the speech also, you can just see that the proposed device is almost coming close to the normal larynx. So that way, by going for this methodology, one is you are making it hands-free, you are making it power efficient, and you are also making it automated, so that whenever someone wants to speak, immediately he can start speaking. Now, apart from powering the device, when you are not speaking, again you would like to reduce the power that is being consumed, because now you have not switched off the battery. So for that, we went for power gating mode. That is, you just see whether there is an intention to speak. If there is no intention to speak, you go for power gating mode and see how long there is no intention of speaking. So we have set some threshold. If that duration is greater than the threshold, you go to power down mode. Ensure that battery is disconnected from the circuit. And if it is within the threshold, then you see whether there is an intention to speak. If there is an intention to speak, generate that pattern, give it to the power amplifier, and the signal is generated. So this is a common methodology that is adopted for power saving. And once if you go to power down mode, now you can come out only if the external reset is given. Again, for reducing the size, it was using NIMH batteries. We wanted to see whether I can use lithium ion battery and all that, and go for power saving. Again, since Electrolarynx was generating square wave, it was generating unnecessary signal, all that was consuming power. Since we went for a methodology where you generate what is required, so we eliminated that something extra that was getting generated by the square wave. By eliminating that, whatever that power that would have been consumed for generating those part of the signal, that has been now saved. So this is just some statistics. Servox was functioning from 40% duty cycle to 90% duty cycle. By going for our methodology, at 90% duty cycle, you see, we have come up with a power reduction of about 86%, whereas when the servox was operating at 40% duty cycle, we could bring the power consumed to 65%. So this is again some static power reduction by going for power down mechanism. Current that is consumed when you go to power down mode is 0.6 microamps. With that, power that is consumed is about 4.82 microwatts. If there was no power down mode, we would have consumed a power of about 0.4 watts. So that way, there is additional power reduction what we have achieved. And the other objective was we wanted to eliminate it, holding it near the neck, and see whether we can make it hands-free. We came up with something similar, something it should look very close to, say, headphone. Today, when headphone is not used, people put it near around the neck. So even though it is electrolarynx, if my design can look like a headphone, then even though for me it is electrolarynx, for outside world it will look like person is putting headphone around the neck. So that was our approach, and this is our block schematic of total approach. So I have a strain sensor, pass through an instrumentation amplifier, pass through a microcontroller, ADC and all, and then I am detecting the threshold level, whether there is an intention to speak or I am outside that window. If there is an intention to speak, then I start sending the data that is stored in the lookup table to a power amplifier and then to the transducer, which will generate the required signal. If there is no intention to speak, then I keep track of the timer. If the time exceeds some threshold value, then I go to the power saving mode. And if it doesn't exceed, I keep on generating the signal, or I go and check whether there is an intention to speak. I'll be in that loop. Once if I go to power down mode, then to come out, a external reset is required. So that was electrical and electronics part. There was a mechanical part also, because it is not enough if you just generate this waveform. This waveform should finally drive a piston and then a membrane. So that again, we did we approached mechanical department, and they helped us in making it more compact, more flatter. And these are some dimensions which we came up with. Even we broke open some old mobiles. Inside mobile also, to generate voice, that is when you want to hear the voice, they also use similar concept. A piston will be hitting a membrane or something like that. The older phones had that. So altogether, with all this approach, with a prototype what we had, we could considerably reduce the volume, we could considerably reduce the weight, and considerably reduce the power. It is open for any queries or any inputs you wish to give me. It is open.
People, children who are born with they have hearing impairment. They do not know their own voice, so they are not able to speak because they do not know. They can't hear. So, is there some means of giving a feedback and then teaching the student? There are a lot of hearing impaired schools. They only teach sign language. But these people probably can learn speaking through this device, and maybe if they are also able to get a signal of what they are saying, it will help other people understand them better.
We have, at present, we have not focused in that direction, but I remember one more faculty from mechanical department a few years back. They were trying to develop a headset type of thing that will actually provide a hearing aid to such people, in the sense that, so he was demonstrating that it is not necessary that you have to hear through your ear and eardrum. So he was demonstrating that somewhere near the neck or somewhere, by putting this headset, what he has developed, you can provide an opportunity for them to hear. So, but that professor is no more with us. I don't know whether that work is still continuing in our health science institute or no.
Does it improve there are people whose voice is very, very feeble. So does it act like an amplifier of their voice? They are able to speak, but their voice is feeble.
Yeah, so it is something like we have tested this on normal people, in the sense that, see, when I want to test it, even normal people who have their natural larynx with them, we can give this device and make them to speak, in the sense that somehow you train them to speak not using the natural larynx, using this. And so once that happens, it is actually, this is helping him to generate the voice. So automatically they call it level of the voice you generate. I'm not talking of audibility. Audibility still, in the sense that intelligibility still has to be improved, but level of signal what you have generated will automatically.
And how much would this device cost? Because these people who come to the school I am talking about are pretty poor.
Yeah, the market, it is costing about 20,000, but actually if you see, it should not be costing more than, say, 500 rupees, because there is no great thing in that. But still, what we did is, we actually approached people who are supplying this, say Servox and all, saying that we have come up with some solution that can make your product better. So can you incorporate this in your product and see whether then our effort in bringing it to market will be quicker, no? So, but they didn't come forward. Probably they thought that once, if that happens, tomorrow we may have our own startup and we start producing and we become competitor for them. Before we close, we work on many such medical applications. We also work with physiotherapy department, because whether it is physiotherapy or say dental department, they recommend some therapy, and when they come back after that therapy, say after 15 days or 1 month, when the doctor inquires, have you undergone this therapy as per specification, they say, but when they look at the improvement that was supposed to be there, it is not there. So doctor failed to understand whether this person has really undergone, did that exercise and then there is no improvement, or this person is lying. So then we are trying to come up with some devices where when person is doing this, can it keep track of that and pushing data to our server so that we get authentic data and validate it. And our physiotherapy department itself is engaged so much that for patients, if they have to do one-to-one observation, they will have to give at least 30-40 minutes. That is too much of time you are expecting in a hospital like KMC where patients are flooded. So can we automate that so that they can dedicate their precious time for some other purpose. And once if you automate, you also have database. What was that data you had in the present visit, the earlier visit, and whether there is improvement. If there is no improvement, where is that improvement expected? And for that, what is that therapy recommended? All that becomes simpler. Similarly, for blood analysis, we are also trying to develop some paper-based sensors. So at present, it is at primitive stage. We are just exploring the various papers and various material that can be used in creating a channel for that. We are also looking at creating micro channels for DNA multiplication, then for DNA analysis, all that. So these are some work, and also on capacitor side, that is energy storage, graphene being one of the material. We are also working on graphene as a material for energy storage. So these are some work we are doing. So probably that could be the topic for discussion sometime later.
Yes, definitely. Very interesting subject as well. So we have one question in the chat box. Does this device produces a monotone, as it's a computer voice or like a natural human voice?
At present, even though we have made it better than the existing one, it is still not coming close to the natural. So it is still robotic. This is there, but when compared to the earlier one, this is giving you a better performance. So that is why I said initially itself, when our body is doing all its activity naturally, we don't appreciate it. When it fails to function, when we wanted to do it artificially, we really realize that how artificial we are. It is very, very difficult to go at least say 20% of what natural ability you have. Thank you very much. Thank you.